Okay, hi guys. This is Tuesday's class. So this is what I would have covered with you in Tuesday class. But since I'm back at school and I don't have like my setup like this, for the last class, I thought I'd just film a video of me doing a few extra problems, which is pretty much what I end up doing anyway, because nobody ever asks any questions, which is, not funny, but kind of funny. So here I am. I'm going to do some video. I'm just going to line up my paper. And I'm going to do a couple more problems so you can see me do extra if you want to see it. So I'm going to practice mass to mass calculation, and you can see me do an extra one. So the question reads, I've got just another sheet here for myself that says, what mass of potassium would react with excess chlorine to produce 156 grams of potassium? So that sounds like kind of scary, but you've done these. So this is the balanced equation that was given. So there's our balanced equation. And so I'm going to write down our known, which was 156 grams of potassium. Okay, and our unknown, what do they ask us for? What mass of potassium would react? I'm going to reread this. Oh, potassium chloride. Potassium chloride. Okay, so what mass of potassium, so our unknown is grams of potassium, would react with lots, whatever we needed of excess chlorine to produce 156 grams of potassium chloride, KCl. Here's our equation, here's our known, here's our unknown. So how are we going to do this? Well, we're going to do the same exact way we do it every time. We take our known and put it over 1. And we let the units tell the story here. So I've got 156 grams of KCl over 1. Okay, that's a start. What am I going to put on the bottom to get rid of grams of KCl? Well, I need a little side paper here. First thing I have to do is look back at my sheet here and say, look at this. The molar mass of a compound in grams from the periodic table is equal to 1 mole of that compound. So I got to find out what is the mass, the molar mass of KCl. I'm just going to get a fresh page. Molar mass of KCl. So I'm going to look it up on the periodic table. I'm going to look up K, which is right here, 39.10 grams. So potassium, I had 1 of them in the KCl. Cl, I only have 1 of them this time as well. And I look up chlorine, and it says 35.45 grams, and I add those two things up. 39.1 plus 35.45 gives me 74.55 grams. So what that means is 74.55 grams of KCl is equal to 1 mole of KCl. That is a bunk bed pair or conversion factor. And it's this top one right here. The molar mass of a compound from the periodic table, which we just solved, is equal to 1 mole of that compound. So this is a conversion factor. We just solved it. I'm going to write it down here so you can just see it on the same page. So I didn't do anything different. I just wrote it down so we could see it. So we can get rid of this scrap. Okay, so now we have a conversion factor. Okay, now we have a conversion factor that includes grams of KCl and moles. So I want to put grams of KCl on the bottom because I have to cancel that unit out. So 74.55 grams of KCl is equal to 1 mole of KCl. Grams of KCl get to cancel. and I'm left with a mole of KCl. Well, that's not what my unknown was. My unknown is grams of potassium. So how do I get from potassium chloride to potassium? Well, I've got a balanced equation here. From a balanced equation, I can get a mole to mole ratio. So how many moles of potassium are here? It's another bunk bed pair. 2 moles of potassium are equal to how many moles of KCl in this balanced equation? 2. 2 moles of KCl. That's another bunk bed pair we're able to use here in this equation. So what am I going to put on the bottom? Moles of KCl. On the top, 2 moles of potassium. So moles of KCl get to go. I've got moles of potassium left. Awesome. Am I done yet? Nope. I got to get to grams of potassium. But at least now I'm talking about potassium because I was able to switch from one compound to another because of this balanced equation. So now I got to figure out what bunk bed goes here. Well, I want to get from moles to grams. How do I get from moles to grams? Molar mass of a compound in grams from the periodic table is 1 mole of that compound. So we're talking about potassium. So let's just move to the page. Molar mass of potassium. Well, I only have one. It's just K. Just boom. You never count this number out front when you're doing moles. You only would count any numbers of the compound in here, not this. There's not 2 potassium here. There's only 1. We already used the 2. We used the 2 here. So we just have potassium. What's its molar mass? There's only one of them. Molar mass from the periodic table. Look it up. Potassium right here. It's 39.10. We already looked that up a minute ago. So what does that mean? 39.10 grams of potassium is equal to 1 mole of potassium. That's a bunk bed pair or conversion factor. And we know we're allowed to do it because it's here. The molar mass of a compound in grams from the periodic table, we just looked at it, is 1 mole of that compound. So I'm allowed to do this. So that's another conversion factor I'm going to write right here. 39.10 grams of potassium is 1 mole of potassium. So there's a third conversion factor. We can get rid of this page. So I've got the nice whole thing in front of you so you can see it a bit. We've used this one. We've used this one. Now we have to use this conversion factor. What's going to go on the bottom? Well, moles of potassium are on the top, so I want moles of potassium on the bottom. 1 mole of potassium is 39.10 grams of potassium. Moles of potassium get to go away. Cancel the unit. The unit that's left here in this whole equation is grams of potassium. Every other unit's canceled. What am I asking for? Grams of potassium. Awesome. I know I'm there. I let the units tell the story. The units direct to me when to use what. Who goes on the top and who goes on the bottom bunk. It's different for every question. Now I just have to do the math. So let's do the math. 156 times 1, which I'm going to skip, times 2 times 39.10 equals, divided by 74.55 equals, divided by 2 equals 81.82 grams of potassium. That's our answer. Okay? So hopefully you can follow along with me doing this. I'm going to do another one here so you can see me do this. Okay, I'm going to do the next one. But hopefully you can see how this may work. I'll flip it over and use the back, save some paper. Okay, here's the next question. How many grams of zinc will be produced if 32.0 grams of copper reacts with zinc nitrate? That's the question. Here's the formula. Sorry, I'm going to rewrite that guy because it's a bit messy. 2CuNO3. Okay, that's the formula. Balanced equation. We get to use that in a few minutes. All right, what's our known? 32.0 grams of copper reacts with zinc nitrate. We can see that here. How many grams of zinc will be produced? So our unknown is grams of zinc. All right, let's see what we're going to do here. Let's figure out, what do we always do? Take our known and put it over 1. 32.0 grams of copper over 1. What's going to go in the next bunk? Well, we're trying to get to moles, grams to moles. Well, how do I do that? Molar mass of a compound in grams from the periodic table is 1 mole of that compound. Okay? So, little side sheet. I just have copper. What's the molar mass of 1 copper? Well, find your periodic table. Oh, where did I put mine? Oh, sorry. I got papers everywhere. Okay, copper right here. I look them up. It is 63.55. So I get to write this conversion factor. 63.55 grams of copper is equal to 1 mole of copper. That's a conversion factor I get to do because I looked it up on the periodic table, and that's one of the rules. So I'm going to write that here. It was 63.55 grams of copper is equal to 1 mole of copper. That's a conversion factor or bunk bed pair I get to use. All right, what's going to go on the bottom? Well, I need to cancel grams, so I need to put in 63.55 grams of copper and 1 mole of copper. My grams of copper got to cancel out top and bottom. What comes next? Well, I'm talking about copper, but I really want to know about zinc. So this is the opportunity where I can use a balanced equation to go from one compound to another. So in this balanced equation, I have the 2 comes from here, 2 moles of copper is equal to 1 mole of zinc. That is a conversion factor I got to pull out of this balanced equation. Once the equation's balanced, I'm allowed to talk about things within that equation being the same number of moles. This is a law. I'm allowed to do this. So what's going to go in my top and bottom bunk? Well, I'd like to get rid of moles of copper. So I'll put 2 moles of copper down here. And what goes on the top bunk? What's his pair? 1 mole of zinc. So moles of copper get to cancel out. Awesome. At least now I'm talking about zinc. Now I have to figure out, I need to go from moles to grams with zinc. Well, I need to find its molar mass. So molar mass of zinc. I find my periodic table. I find zinc is right here. It is 65.38. 65.38 grams. So that means I get to say 65.38 grams of zinc is equal to 1 mole of zinc. I get to say that. Okay, so right here, 65.38 grams of zinc is equal to 1 mole of zinc. That's a conversion factor I get to use. Who goes in the last top and bottom bunk? Well, moles of zinc are on the top, so I need to put moles of zinc on the bottom. 1 mole of zinc, I've got that right here, is equal to 65.38 grams of zinc. Moles of zinc, moles of zinc. How does this play out? Let's see. I need my calculator. Multiply all the top. 32 times 1 I'll skip, times 1 I'll skip, times 65.38 equals, divided by 63.55 equals, divided by 2 equals 16.46 grams of zinc. That's the answer. Okay? So there I did 2 more for you. Hopefully you guys can see this moles to grams and how this would work. If you're having any other questions, just ask me one-on-one and I'll be able to sit and go through this with you and find out where your problems are. Okay? All right. Have a good day. Thanks. Bye.